Questions really quickly, friends, and then we're going to talk through this and keep cruising. So a couple of logistical questions that are coming up now. What is the Slice of Earth project? We did that. It was like the very first thing that we did. You guys colored that, and then you were supposed to answer some questions. And that was something that I had said, you need to make sure you do it for tomorrow. And some of you did, and some of you didn't. And if you didn't, and you have it done now, then we'll figure it out. But we're going to do this first. So I don't want you to worry about it right now, okay? I want you to worry about it when we're doing our review stuff, all right? There was a question about what the test is going to look like. It's primarily multiple choice, just like most of our tests, right? There's a little bit of matching. There's a little bit of like fill in the blank kind of things with some vocabulary words and stuff like that. But that's pretty much it. There's no like essay question type thing. Okay, if that was your question. Okay, you guys okay? Is there something like, do I look really funny? Like, what's wrong? Like, I know I am, but like besides that, like, is there like, do I have like snot hanging out of my nose or something?
Bolt day.
You want to guess? I don't know.
Yeah.
I know, right? Yeah. I mean, no. Well, yes, there is judgment there. All right. Shh. Ladies and gentlemen, my friends, I'm going to give you a choice right now because I don't want to fight with you today. Okay? When I ask you to be quiet, either you can be quiet and we can go through this content that will, yes, be on the test, or I can just let you talk. Okay? That's not going to get you the material you need. That's probably not going to get you where you need to be for the test tomorrow. Okay? I know that it's the week before winter break. I feel it too. I know that it's a beautiful day outside. I feel it too. I know that your teacher is wearing a tutu. I know it because I'm wearing it. But that does not mean that when I ask you to be quiet that you ignore me. Okay? That's disrespectful. And it's not just disrespectful to me, it's disrespectful to everybody else. I know for a fact that there are some students in this classroom that need or want to learn this material. Okay? So you need to show some respect. Got it? Okay. Hi. I don't think so, but I can hold on to them. I've got a bunch.
Did you give some to me?
I did. Yeah. I don't know. Yeah. I'll put them here and deal with them later. Thanks. No, it's okay. I don't know. It's a mystery. They just keep coming, I guess, or something. Who knows? All right. Are you ready to learn? Can we start this process? Okay. Great. All right. Here we go. So the capture question said, describe the density of magma, its variation as temperature changes, and its density relative to water. So there are kind of like two questions there. Who's got an answer to one of those questions? You just had some time to talk. You have a blue sheet that I don't see very many out, so maybe it's a good idea to pull that out. This is where we ended yesterday, my friends. We ended yesterday with this, so if you don't know, then get your sheet out and look it up. Take responsibility and ownership for your learning. Don't rely on the loud kid, okay? Shh. Yes, it is Tuesday. Yes, I haven't moved it. Just relax. Jack, can you get us started, please? Not right now. Not during my class. Go ahead, Jack.
So since magma is molten rock, it's going to be more dense than water. So it will go down to the bottom, or it will go below the water, even though it's hotter than the water, or the whatever the core.
Okay. So oops, it's on freeze. You can't see all that great stuff that I wrote. So I want to make sure I understand what you're saying and just put the science in there. So you said that magma is molten rock. Everybody agree with that?
Yes.
Indeed it is. Okay. And that in and of itself, you said that it means that it's more dense than water. What evidence do we have? What physical evidence do we have that it's more dense than water?
Rocks sink.
Yeah.
In a pond.
Not all rocks sink. Did you know that? Not all rocks sink. What evidence do we have that this molten rock, this magma, that exists where? Where in the earth does this? In the mantle, right? So if you look at a slice of earth, anything that's going to float has to be less dense, doesn't it? So if we think of a slice with the oceanic crust, so we've got the oceanic crust right here. What's on top of the oceanic crust?
The ocean.
The ocean. So that's the water, right? So you've got water, and then you've got the oceanic crust, and then you've got that magma down here. And so therefore, this is the process that I want you to understand, friends. This is the process. The most dense or the more dense thing is going to sink, right? And the less dense thing, in this case, the water, is going to float, okay? How does my density compare to the density of the floor?
The floor is more dense.
It's got to hold me up, right? Yeah. Yeah. So my density overall is less dense than that of the floor. Otherwise, I would sink. Does this kind of make sense? That's what we're talking about. That's what we're talking about. The density gets more and it gets higher and higher and higher the lower you go into the earth. Okay? Just like with our ice cube yesterday, just like with our block yesterday, all of that stuff is true as well. Yes, what's up?
Hot magma flows to the bottom and the cool magma rises because hot magma is it's less dense. No, isn't hot magma more dense? It's less dense.
That's the question, right? So which one? So let's think back because this is exactly where we're going to go today. So let's get it and make sure it makes sense. So I'm going to draw my little slice of earth again, right? Zoop, zoop. And so here's the mantle. The mantle lives from here to here. And where, just kind of by virtue of being in the earth, will the magma be the warmest? Will it be warmest closer to the center or further away?
At the top, because cool air, the bottom. Cool air, like
Okay,
air
okay.
raises.
Yes, I want you to answer the question prior to any motion happening. Where is the magma going to get warmer? At the bottom, right? Because the further down into the earth you go, the hotter it gets. Okay? So the hot magma will be here at least for a while, right? But then what were you saying, Hannah?
Hot air raises.
Okay, and is this air?
Switch. No, but I feel like it still be the same. Because it's still warm and it rises, but I think they switch and the cool would go down to the bottom. And then the cool would get hot at the bottom and then they switch.
Yeah? Does that make sense? So the thing to remember, here we go, right? We wrote this one down yesterday. The thing to remember, number 2, objects made from the same material have different densities. The warmer the material, you just said this, right? It's going to be less dense. And if it's going to be less dense, then what does that mean? Is it going to float or sink relative to other material? It's going to float, right? So this is the funny part because this is why all of this stuff happens, right? You have cool magma up at the top relatively, and you have hot magma down here at the bottom. But as Hannah just said, the hot magma is, what did you say about the density? Less dense. Remember, those little molecules are moving around more. If they move around more, then it's going to be less dense. So the hot magma is less dense. Oops. Trying to put it all together. And as a result of it being less dense, it wants to float to the top. The cool magma that's up here, tell me about its density.
It's more dense. So
It's more dense, right? The cooler it is, the less those atoms and molecules are moving, the more dense it's going to get, and the dense stuff wants to sink. Okay? Is that kind of making sense? All right. Yesterday, here, I want to make sure that I'm on the right place here. So yesterday we drew this picture. So pull out your blue sheet if it's not already out. Okay. Pull out that blue sheet, the one that started off saying, I don't know, convection currents at the top. It looked like this. We're on the back. So we were recalling yesterday that hot magma is at the bottom of the mantle. It's less dense. Hey, we just wrote that down again. And then I showed you a video, but we didn't quite get all the way through the video. And it's an important video to watch, so we're going to watch it one more time. So here it comes. See if our sound is on today. Digital output is on. Ads.
Oh, it's the same ad.
I know, same ad. It's very consistent.
Get ready for one of the most hypnotic things.
What did I just say, Jack?
See in this
We did.
place.
We totally watched it. We started it. But we're going to watch it again because it's important.
I thought you said we did it.
Oh, we did. Yes, we did.
Have you heard that heat rises? Well, here you can see it's true for yourself. I've got some food coloring on the bottom of a plastic container, and there's a hot mug right underneath the red food coloring. As it's heated, the water rises. But I want you to look closely and notice something else. The blue on the sides is being drawn in. You can see it better when I speed it up. Here's the thing I want you to remember. When water moves from one place, it doesn't leave a void behind. Water from somewhere else has to move in to take its place.
That's true for magma.
That's why you can see the blue food coloring coming in from the sides. You can see it better from above. Watch that blue food coloring get drawn in. Do you see it? The hot water reaches the top, and then it gets pushed toward the edges by more hot water rising from underneath it. As it goes out to the edges, it starts to get cool, and cool water sinks just as hot water rises. And if you watch really carefully, you can see it sink and get drawn back toward the middle. These are called convection currents, and you see them moving here in two big ovals. They're one of the major things that drive ocean currents, especially in the deep oceans. But it's not hot water rising that drives the ocean currents. It's really cold water sinking up near the poles. Here's a piece of ice that I froze with some blue food coloring in it, so you can see how cold water sinks. As water sinks at the North Pole, for example, water has to flow up from southern regions to take its place. And these currents travel around the globe, some of them taking 1,000 years to complete their course. Understanding convection currents will help you get a grip on weather systems and the movement of Earth's continents over the eons, and even the workings of a lava lamp. If you want to try this for yourself, click on this link for all the directions you'll need. Thanks for watching.
All right. Oops. So, hopefully you were able to see those currents, right? He was saying in the video, the narrator was saying that it has to do like this, the convection current stuff has to do a lot with ocean currents, right? And that's true, but we don't really care about ocean currents yet. We will get there later this year and we'll talk about them. We'll talk about climate and all of that. But did you hear what else he said these convection currents were related to? Did you catch what he said? It was kind of at the end of his sentence. Besides ocean currents.
The weather.
Besides the weather. The continent's moving, yes. So we've got to write one quick thing down for the application picture. So in that little section on your sheet that says discuss and draw, you do not have to draw this detailed picture, but I do want you to draw this. This is kind of a sketch of what the video showed. The things that are important for you to have are to know that you have warmer water here, right? Okay. And then what happens to that warm water? What happens to the warm water? What'd you say, Libby? It floats. It rises up, doesn't it? The warm water has a low density. So it's going to rise up like this, right? It's going to rise up. And as it does that, it's not like the water just like starts to levitate, because there's going to be cooler water, this cooler water that's just up at the top, just hanging out, just not getting heated up quite as fast. This cooler water up here, which, oh, by the way, is more dense, starts to fall down, right, to replace that warm water. Low density. The cooler water is more dense. And so what we get are these little circles, these little currents that happen vertically in the water. They're called convection currents. And that's literally, so this happens a lot. When you're making your mac and cheese and you have to warm it up, I'm not talking about the like instant mac and cheese, but I'm talking about like if you're actually doing like the blue box or, you know, even more real, okay? When you put a pot of water on, literally the water from the middle starts to move up and starts to bubble up, and this current stuff happens, okay? The other piece that he did not put in that video, but that is important, what do you notice? What is up here? What are those? Little blocks of wood. Now tell me about the density of the blocks quickly as compared to the water.
Less dense than water.
Less dense, and how do you know that they're less dense, friends? Because they're floating. Yay for us. Okay. That's what I was just about to ask you. Why do you think that these blocks have arrows on them?
Because the warm water is coming up.
It's coming up and it's going out, isn't it? And so those convection currents, what are they doing to those blocks? Pushing them away. Are you with me there? Yeah, this is a big deal. Because now the convection currents are causing these wooden blocks to be pushed away, to move. These things that happen to be floating on this liquid are being pushed just because of changes in density.
So basically they're being pushed away from each other?
They are absolutely being pushed away from each other. They are absolutely being pushed away from each other. Are we doing okay so far? Yeah? We've got a thing to remember to write down, and then we're going to do one more step. We're so close. Holy cow. You ready? Here we go. Thing to remember number 3. Here it is. Liquid magma in the mantle experiences convection currents as warm magma rises and cooler magma descends down deeper where it warms again. Liquid magma in the mantle experiences convection currents as warm magma rises and cooler magma descends down deeper where it warms again. Bless you. Bless you. My goodness, we're just a sneezing symphony today. So the magma's not on the top of the earth, right? Not at the very top. What's sitting on top of the magma? The crust, right? And the crust floats on top of the magma just like the wooden blocks floated on top of that water, right? And so as that magma has convection currents in it, what's going to happen to the crust, my friends? Indeed. So here we go. Let's write this down. We're just going to write down what you just said there, okay? Oh, yeah. I'm sorry. Were you not done? I'm sorry. I just got excited. Science is fun. Are we good now? Not quite? Almost? All right. So in this little section where it says connect, we're just going to write down what we just said. So the crust floats on the mantle just like in the same way that the blocks floated on the water. And the convection currents will move the crust just like the convection currents move the blocks. Okay. I want to show you a picture to kind of describe this. I will leave it for just a second. Yep. So the crust floats on the mantle is just pretty much the same game as the blocks floating on the water. The convection currents move the blocks. The convection currents of the mantle will move the crust. This picture is going to illustrate it very nicely here. Are you ready? Here it comes. All right, so that first one is the same one we just saw. But the second one is like the equivalent looking at the Earth's crust. You just need to draw the second one, but I wanted to show you the nice connection. Say what now? No, so you do not need to draw the one on the left again, because you kind of already drawn that one. But what I want you to draw here, I'm going to help you, tell you exactly what to draw. But I wanted you to look at this. So really what you've got here, friends, you've got the mantle. Right, with the hot magma down here. And up here, you've got cool magma. Okay, so you've got hot magma down at the bottom. You've got cool magma at the top. You know that the density of the hot magma is bigger or smaller than the density of the cool magma? It's smaller. It's lower, right? The hot magma, I'm just going to put a parentheses here to remind us that it's less dense. So it's going to rise up. And in doing so, this is like the big money piece right here. Just like the blocks moved apart, what's going to happen to the crust right here? It's going to move apart. What is this?
A volcano.
It's a volcano at a what kind of fault? Or not fault, a what kind of boundary? That's what I meant to ask. Divergent boundary. That's exactly how it works. This is why it happens. I love this because it's like, this is the reason. Not just memorize divergent boundary. Now you know exactly why it happens. So this is a divergent boundary. And the divergent boundary happens because the convection currents are pushing that crust apart, right? And in that place where there's nothing, magma's going to come up, creating a, you told me before, volcano. Yeah. And in this case, it's underwater. Do you see that? It's an oceanic divergent boundary. And what are we going to get under the ocean where we've got that divergent boundary? Do you remember what that's called? Blank, blank, blank. There are 3 words. Remember what that's called?
Oceanic.
You're close.
Oceanic.
We get this set of volcanoes that go all the way down the ocean. Do you remember what that's called? The mid-ocean ridge. Yeah. So this is a volcano chain that creates the mid-ocean ridge. This is a great review in and of itself, my friends. Right here. Now, that's not the only thing that this picture has. This picture also shows, so this is oceanic, right? Over here, you've got some continental crust. Do you see that? And you've got this oceanic crust that's doing what? Do you remember what that's called?
It's
Where it goes down?
a convergent.
This is a convergent boundary. That's true. Let's write it down. This example of a convergent boundary is a continental oceanic convergent boundary. One of them goes under the other. Do you remember what that's called? Starts with an S. I'm looking right here at that space right here. Where you've got one piece of crust that goes under another one. Starts with an S. This is a good word. It's on the test because I wrote that question. What is it? Subduction, yes! Convergent boundary, we know that there is subduction. Subduction means that one piece of crust moves below the other. Which one goes under?
The oceanic.
And why? Think density. So which one's going to go down?
One's more dense.
More dense, right? No, yeah, more dense. Yeah. So it has to do with density, right? Subduction, density. Yeah. Right? And what else was I going to point out? Oh, yeah, so you got subduction. And what is created there? Just, to add all these pieces. You get a trench. And you also get some mountains. Yeah, look at all of this cool stuff. I'm sorry. I'm just excited about all the cool things that are in this picture. So maybe just put a little note. Oh, yeah, and there's a trench.
So all you have to write is trench.
And then we've got this one over here. What are these guys? These are mountains, right? How are we doing? This is cool, right? It puts it all together.
What creates it? Where's the trench?
The trench is right where the subduction happens, right here. Where one goes under the other. There's a trench there, and then you've got folded mountains up here next to it. It's a big deal, friends. All right. One more thing to write down. Can I put it up? Things to remember, number 4. Convection currents in the mantle are responsible for the movement of the Earth's crust. This is the reason that it all happens. This is what Alfred Wegener needed to know, right? Who was that guy? What did he do?
No.
He came up with the plate tectonics, right? So many years before everybody else. Do you want me? I can play the song again.
No.
Yes.
Do it.
I'll send you the link. It'll be okay.
Do it.
No.
Stop. Okay.
Can you say stop it now from now on?
No. I feel like that's a thing, and I don't want to be a part of that.
Stop.
It's a good thing.
The creation of new crust at divergent boundaries and the destruction of crust at convergent boundaries. This is the big deal, you guys. This is it. Like, holy cow. I'm just moving that down so you can kind of see them as 2 separate things. It was a lot of words. All right. That is it. I'm not going to move it. I'm going to let you think about something right now. We've got about 10 minutes before the end of the period. Okay. I'm going to give you a choice. We're going to vote, and highest vote wins. Do you guys know it's voting day today? There's a special election. Remind your parents to go vote. Johnson County Supervisor. Takes 5 seconds. I was number 5 at my polling place this morning at 7 o'clock. Woo! Anyway, I know, right? Listen to the choices. Please listen. We can either do some studying on your own. You've got a study guide to work on, and that would be one option. Option number 2 would be to play bingo, which is a review process as well. I do not feel strongly. Let me ask this question. Raise your hand if you would like bingo. Okay, so there's a lot of people that want bingo. So let me tell you the deal. Listen carefully. Now's quiet, please. If you are not interested in playing bingo and you would like to go to the back somewhere and study, you are welcome to do that. If you want to study with a partner, as long as it's fairly quiet, you are welcome to do that. If you would like to play bingo, send somebody from your table up to get a bingo sheet. Right up here.
Not me, I got the last one. Bro, my arm is hurting.
Yep, you can grab right there. They're right. I put them right over there. Yes, what's up?
I'm not. So, the cold mornings, top of the mantle.